starts, or maybe a half hour. So I figured I would jump on and do some leak coding quick. Got 2 or 3 problems lined up, but not as much time to stream today as I sometimes have, so I probably won't be on that long. And because it's early, I have my Klingon coffee cup. I'm trying to get it in front of the camera. Got my Klingon coffee cup, which I guess makes this a Rock to Gino, if you're a Star Trek fan, and if not, you just think I'm a nerd, which is fine. So I might be drinking that off to the side and go on mute every once in a while to take a sip, but we'll work through it. Okay, so without further ado, let me jump into the problem. So this one is maximum depth of a binary tree. Given the root of the binary tree, return its maximum depth. A binary tree's maximum depth is the number of nodes along the longest path from the root node to the furthest leaf. So I think this is one that I've implemented not too long ago. I don't think I did it on stream, but I think it's going to fit pretty well into a recursive solution. So let's go with, we're going to recurse, or recurse to find the depth of left and right nodes. Return the longer one, +1 for current node. Base case for, and I didn't really think to do this quick, but I think the size looks good. I think I say this at the start of every stream, but if you need anything bigger or smaller, just feel free to jump into chat and let me know. Base case for current node, or I think I'm actually going to handle this here. So if next node is null, depth is 0. And then 3, return value found from recursion. So I think this shouldn't be too bad. We're going to recurse into each tree and find the longest leg. So in this case, it's going to be 1, but I guess I don't have an example. But if we had, let's say 5, and then 3, drawing out ASCII graphs is always a pain. And then, let's say 6, because it's not a balanced tree or anything. And then on this side, if we just had 6, then we would want to return, we would recurse down and just return the longer node every time. And if we had, say, this, then we would return 2 from 3, and 5 would get 1, 2, 3 jumps, and so 2 plus 1 is going to be 3. So let's go ahead and hammer that out. It shouldn't be too bad to do. Private int max depth helper root. So, as always with recursion, we're going to go ahead and set up our base cases. So if, or rather here, we're going to do int left depth equals 0, int right depth equals 0. And then if root.left is not null, then we want to update left depth to be max depth helper for root.left. If root.right is not null, we need to do the same thing on the right here. Then root.right, or rather right depth. Oop, and actually, I'm going to pause 1 second here. I watched chat on the Twitch app on my phone, and it looks like it died on me. I have that every now and again. There we go. Where it's just trying to reconnect and it can't pull up chat. So I've got that up now. but it's before 7 a.m. Central. So if you're on the East Coast, it's a little later, and if you're on the West Coast, it's a little earlier. So it might be a quiet morning. Max depth helper, root.right. And then here we are going to return, so actually, I think I'm going to take care of the addition here. It doesn't really matter, but that lets me just do right depth greater than left depth, right depth, else left depth. So this is just a style thing. I'm always on the fence about ternary expressions because if you're not familiar with the language or you're not a software engineer, these aren't apparent what it's going to do. Once you understand it and you've kind of seen an if statement written out like this, then it makes a little more sense, but off the bat, it's kind of tough. But this should actually handle it for us. So then let's return max depth. Although actually, yeah, so this should work. So I should just be able to return max depth helper for root. And let's give that a shot. Okay, so we are off by 1. So what's our, let me see if I can understand. So 1, 2, or the number of nodes. Okay, so it's not the number of edges, it's the number of nodes. So really this should be starting at 1. And if I've found a node, then this is going to be 2. I don't like that, so we'll see if we can clean that up a little bit. Or no, I think 1 would actually do the trick. So here, well, no, this does need to be 2 because I'm resetting left depth. So we'll see if we can't. And you know what, maybe just a better way to do that would be if left depth is not null, left depth plus left depth gets that. If right depth is not null, then we add the depth that we found onto right and left depth. And that is very not right because I left +2 on the end of that. So let's try that again. Okay. So let's try the other test cases. As soon as Leetcode is happy to let me try. Okay. And that's, so the output looks correct there. Let's go ahead and submit it. And then I'm just going to see, oh, okay, so if root is null, then the answer should be 0. So if root equals null, return 0. There might be a way to handle that inside of the recursion. Okay, so we're right on the edge. I don't know if there's much we can do to optimize this. Let's poke around for a minute. because I have to iterate both of them, or I have to recurse into both of them to know if one is larger. And if I can't recurse into one of them, then then I don't. So I don't think there's a whole lot of optimization that I can do here. I might be able to do it iteratively, but that's going to be quite a bit tougher. Oh, okay. And that's the thing about Java is, for whatever reason, my next run, I know I complain about this every time, but for whatever reason, my second run allocated like 800 kilobytes less, which took a millisecond less and just went off. So I kind of wonder if I run it again. So my personal theory is that behind the scenes, Leetcode must be allocating some kind of a JVM sandbox. And I wonder if my first iteration took the hit for that, and if now I'm just connected to the same sandbox, although my memory is still going up and my time is pretty good. So there may have been some like JVM initialization in here. And in just a second, I'll stop theorizing that because I'm sure nobody else cares. But I think that's a pattern that I will keep my eyes open for, is if your first run takes longer than subsequent runs for the same code, then my theory will be that Leetcode behind the scenes is handing you your own little JVM runtime, and it incurs some startup cost in this first one. Okay, and I didn't have this one on my list, but I think that it's essentially going to be if or description. Where'd it go? Yeah. Okay. So I didn't have this one on my list, but I think it's really just the reverse of this. So as cheesy as this is, I think to just pick up the Leetcode credit, I'm going to just reverse this sign. So if I'm trying to get min depth, what I want to do is find the smallest depth. So it should just be picking the opposite. And then I need to do the same. If root is null, then return 0, else return min depth, not mix depth. And I would expect that to work. That is, I would expect it to work as soon as I finish updating all of the method signatures that I had in here. Okay, let's try that. Okay. Do they have an example for? Nope. Okay. So a leaf node. Okay, so there is an extra criteria in here, which is a great argument or point for always reading the requirements before you start coding. So it's not enough to just test um, if they're which one is smaller, because if you have a child, then you need to recurse into it. So it's really just if there are no more children below me. So I think I need to handle this in a slightly different way. So okay. So 0, 0. If I can recurse into them, then I will. I'm not going to do this anymore because I think that's going to be a little difficult to get into here. So if okay, so really what I want to know is if and I think I'm going to wind up doing an extra check up here, but if root.left is null and root.right is null, return 1, because I found a leaf node, and that's one node on the path from root to leaf. But I don't want to recurse down at all. So now I want to know if either of them are null. And if either of them are null, so I think I need to do that check. So if right is null, then return left. I think I could actually put this back in. We'll take a look at this real quick. Okay, so if root.right is null, then I want to return. So I already checked if they're both null up here. So if root.right is null, I know root.left is not null, and I want to return left depth. Else if root.left is null, then I know that root.right is not, and I want to return right depth. Else I want to return right depth less than left depth. Return right depth, else left depth. So let's walk through that for just real quick. So we're going to seed this with 1 because I found at least one node. If this is my end, then I'm going to return 1. If they are both null, then I found a leaf node and I should return 1 because it's just one extra node on the path from root to leaf. If root.left is not null, then I want to recurse into it and build out the depth there. If root.right is not, then I want to recurse there. If root.right is null, then I want to return left, whether it's shorter or not, because that one actually had a depth. Reverse, and then if neither of them are null, I want to return the smaller one. So let's try that. Okay. Okay. $16 milliseconds. Goodness. 4 milliseconds. Yep. Yeah. So I think that to me is another piece of evidence towards it where Leetcode must give you your own little sandbox for running your solutions. Well, no. Back up to 16. Fascinating. So is there anything we could do to optimize this? I don't really think that there is much because we're only recursing when we need to, so we're not recursing if we don't. We might be able to reduce the number of checks here, but I don't think it's going to be significant. So yeah, nothing really obvious is coming to me for ways to improve that, so I think I'm gonna leave it at that. And then let's take a look at this one. We'll take a look at one more this morning. I've only got maybe 10 minutes left in what I'm going to stream today, so we'll see if we actually make any progress, but it's always worth a shot, right? So given a non-empty array of integers nums, every element appears twice except for one. Find that single one. You must implement a solution with a linear runtime complexity and use only constant extra space. So given a non-empty array of integers nums, are there any constraints on the numbers? Nope. They can be really big or really tiny. So the first solution that I'm thinking of is to sort nums, iterate nums, looking for, or iterate nums, checking if two elements next to each other match, return first element that doesn't match. And I think this would work because technically it is linear. This is going to be a sorting algorithm, and I think Java would have a log n sort. Yeah, bubble sort is not going to be what Java has implemented. The one thing I don't know is if the sort, or no, so yeah, it would be n log n, probably, depending on what they choose. But n log n, okay. Okay, so assuming I get an n log n sort algorithm, then sorting this is going to be big O of n log n. And then iterate the numbers is going to be, in worst case, it's going to be O of n. So then our total runtime is going to be O of n log n plus O of n. This is maybe something I should do more on stream, is analyze the runtime of what I'm doing, just because that's a big part of interviewing, is being able to show the runtime that you've got, or the runtime that you have in your algorithm. So let's give this a shot. We'll see if it actually meets the requirements. So arrays.sort nums, and that's just the built-in sort function for arrays in Java. And then for int I equals 0, arrays.length minus 1. Okay, and then in here, so if nums at I is not equal to nums at I plus 1, then return nums at I. And else, and here I need to actually need to skip an element because I'm going to be iterating. So if my array is 1, 1, 2, 2, 3, 3, 4, at first I'm going to be comparing 0. So I'll start by comparing 0 to 1, which would be fine. But then when I go to I equals 1, I'd be comparing 1 to 2. And that's not what I want to do. So I think we're actually going to increment by 2. So we'll start at 0. We'll jump to 2. And that works because we have pairs. If we had a different number of duplicate elements, we could always just change this incrementer, but that should do the trick. And just because I haven't done this in a really long time, I think that just gets evaluated as a statement in Java, but I'm not too sure. So let's just do I equals I, and nums at I is so I'm just printing out what my loop is going to be doing, just so that I can see where we land. So let's give that a shot. Missing a return statement. So this should never be possible if these constraints are true. There are ways that I could get around having Java do that. Like I could set the store it in a variable and then do a break and then do a return on the variable. So we might go there, but for now, let's just get it working. Okay, that's what I was expecting. So let's try it on a few more example test cases. And then we will drop the, well, apparently not. Output was -1. It should have been 1 and 4. Okay, so let's, of course, there's a single element edge case. But let's figure out what's going on here first. So I would expect this to work. 1, 1, 2, 2, 4. So 0 and then 2. Oh, and then I had that in there thinking this might ignore the last element. Yeah, okay, array index out of bounds. So I think really here, in this case, I know that it's the last element. So I think so I do need -1, and then let me type it out, and then I'll talk it through and see if it makes sense or not. So I can't iterate to nums.length minus, or nums.length, because that's going to make me skip ahead 1 and go out of the array. But if I make it to the end of the array and I haven't returned, then I know that it's the last element that doesn't match because I've checked everything else in the array. So then in that case, I'm just going to return the last element because it has to be the largest element in the array that didn't find a pair. Okay. So let's see if that works on just one, or an array of length 1. And it does. So let's comment this out. We'll go ahead and submit it. Okay, and testing my Leetcode gives you your own tiny sandbox theory. Yeah, well, Okay, so then is there anything else I can do to optimize this? And I don't know that there is. Um, it would be nice if I didn't have to do, because technically O of n log n divided by 2, so this is an n log n solution, so it's not linear. It's better than n squared, so I think I missed it. A linear runtime complexity and use only constant extra space. Hmm. I might have to do some reading and thinking about this one, because this isn't linear complexity. It's O of n log n, and I'm trying to think if there's a way that I could improve it. But if I don't know that the array, it doesn't say that the array is going to be sorted. So I'm not sure. I will have to do some thinking on that one. But in not too long here, I got to start my day job. So I'm going to stop the stream and drop off. Okay, interesting. My frame drops are going crazy in Twitch. So I don't know why that would be, unless it's because I'm starting to drag everybody through this. But I'm going to go back to. Nope. Um, okay, yeah. So I think it's when I go into chat that my frame drops start to go crazy. So I think it's that it might be that my camera is too high resolution or something. So I will play with that. I will see if I can find a way to improve that so that when I end and start, it doesn't go crazy. But anyway, thanks everybody for hanging out.